I'm going to talk about object storage. And to my knowledge, it kind of get the trend thanks to Amazon S3. So I'm going to start with the introduction of the talk today. I'm going to show you what's object storage. I'm going to also show you what's Amazon S3 and what's all about. I'm going to show you also some use cases related to Swift and why it can be interesting for you guys in your company or for your customers. Later, I'm going to more or less briefcase the history and the architectural decisions taken into the conceivable of Swift, some features, also some API examples. And at the end, I wanted to show you this a demo with Cyberduck, but due to time constraints, I'm going to show you just screenshots because I cannot connect my MacBook here. Nonetheless, I have my computer here, and for the barcam, it can be a subject of exploration. Okay. So I'm going to stay here, by the way. So what's object storage? I've come across this question many times already in my job, and it's quite hard to explain. My best approach is to tell you it's like regular FTP or WebDAV storage. You treat files in this language, you call them objects, and you treat folders, and you can call them somehow buckets. But the idea behind is to use only HTTP as a protocol. So it's easy to access from an application for a PHP developer to get files over HTTP. It's like a curl open. And the idea is to have also added features like security access or metadata around the objects, so developers can put their stuff on that. Also, everything is a URL, and by default, you get a URL that looks more or less like a folder/file. And the idea is also that you have unlimited capacity on this storage. So you as a developer, you don't care how much space do you have left. Like you just put stuff and you just read it. There is also no concern of operational concerns from the developer's point of view. You don't need to worry about fragmentation. What happens if you remove or add files again, back and forth? You just forget about all these operational problems. No logs, concurrency problems. Everything is dealt on the application. And also, there are partial reads or writes, so you can read a file from the middle, even if it's huge, and so on and so forth. It was designed for this era of the cloud things. Everything is cloud nowadays. So it's secure, reliable, scalable, fast, and expensive, and simple. More on the following slides. So as an example of what an object storage service looks like, I'm going to introduce you to Amazon S3. Once you sign up to Amazon S3, you get like a website where you can put folders and files on it. Okay? And on every folder or on every file, you can add permissions, and you can allow only upload to a folder to a certain colleague of yours, or make it anonymously readable, so like a public-facing folder, more like an FTP anonymous folder. Okay? So it looks a lot like an FTP, but you have added features. Like if you can see on the bottom right, you have options to publish a website, or publish a folder as if it was a website. So you can straight to internet, and you just need to make an alias DNS to this URL. So it's like you don't have to talk with the administrator on the back. If it was a FTP, you really would have to worry about the server details and be in contact with the administrator of the FTP server. So S3 was created, and nowadays it looks like this. The idea behind Amazon S3 is to provide content storage and distribution, to provide also a storage solution that is really scalable and actually is limitless. I really don't imagine how you can let S3 out of space. Like it scales like to thousands of petabytes, something like that. You just pay for it if you have the money. You will see some numbers later. So people use it for the storage, for instance, of data analysis, like huge CSV files and things like that. They can control the access to every single file or folder or bucket. This also used as backup or archiving solution, or even disaster recovery. Like if you have a Samba folder and you just want to replicate everything to the cloud and put a very strict ACL, so only you as a super admin can access that, and that's your DRP. Why not? I mean, it's quite cheap. You will see numbers. But there is an even cheaper option called Amazon Glacier, which is like 10 times cheaper than S3. People tend to consider Amazon S3 a content distribution network, and you can use it as a CDN, okay? Because it's fast. You can download at petabytes per second speeds from around the world. but it's not meant to do that. Because if you do that, you'll probably be using a single region on Amazon. And if you want to have low latency for downloads or uploads in Taiwan, you're better off a CDN. And that's why Amazon offers a CDN called CloudFront. Cost, prices. So putting you here some numbers. I use a calculator, by the way. Probably you know the Amazon calculator cost. But you put, for instance, 1 terabyte of regular Amazon S3, it costs $85 per month. Okay, so it's like a cell phone in Canada. So it's really cheap. And if you upload or download 100 gigabytes per month, you just pay 12 extra bucks. You can even get cheaper storage if you just accept 99.9, which is like, correct me if I'm wrong, but maybe 1 day of downtime per year, something like that. And also you can go to Glacier and look at the numbers, $10 for 1 terabyte. Like again, not a USB drive of 1 terabyte is more expensive than that. So Amazon S3, again, it appeared a couple years back, 2008, but people started to worry, NSA and spies around. So what's up with my files? Can I put my CRM files on that? Or can I put my, credit information on the cloud? Probably it's not a good idea. Does any of you guys have been contacted by a boss saying, what are you putting on the cloud? Don't ever put any sensitive data on the cloud? I mean, is this a problem for you guys? Someone? No? You? One? OK. Two? Of course it's a problem, right? You will see later, if you want some numbers, I have some additional slides and some examples of how much it actually costs to build a Swift cluster. We have people here who have built it. I'm my company, but I don't have the experts. I have CloudOps as an example of people who know the issue, and I think iWeb has some experts as well. And they can confirm you that you just have to put regular servers with SATA drives, 3 terabyte drives, something like that, like over-the-shelf drives, and put them all together, just install Swift and let the magic happen. And you will see the cost, the price per gigabyte is quite low. So Swift appeared as a solution to offer object storage. It's very scalable. It runs on hardware which available off the shelf, and it offers more like an S3 solution. It's not a hard drive or NFS share or block storage. It's not a storage area network, and again, it's not a CDN. Okay, so it follows more or less the same approach as Amazon S3. More detailed use cases. People put customers on Swift because, again, the ACL mechanism is so powerful. You can control who access to what, and you can create groups and do ACLs on that. You can, again, put backups, as we said, put your content in it, and right-click and say this thing goes publish and is publicly available. So you serve static JavaScript, CSS, and images on that. And also large object support. Like, I've been learning a lot of this thing lately. Again, I'm not an expert. I'm like enlightened about the features. And you can upload like a, 20 gigabytes file and download it. And you don't have to wait for the application to happen. It's like it's split, and it can do things in parallel to go faster than you would expect. So some history, how this software appeared. It was internally used by Rackspace, 2008. What they did is like a database holding metadata, to decide on which server, a bunch of servers with a central index of where is the stuff stored. And eventually they come up to some scale-out problems. So they re-architectured the thing, and they published the code. It's written in Python, for those who like Python. There is an option to have an API compatible with Amazon S3, so you can even use the same tools. Again, that's the end goal of this presentation, to show you Cyberduck, which is a software that connects to both Amazon S3 and OpenStack and on Swift. And well, it's been since 2009 in production in Rackspace Cloud Files, so it's been like almost 5 years. And there are a lot of companies that run Swift in production, and it's one of the biggest storage softwares in the world if you consider the size of the deployments. I mean, Rackspace Cloud Files, they claim to have like tens of petabytes, something like that. And it just works. Anyway, I don't have the details, but CloudOps have a big cluster as well. And the idea is also to have distributed everything, not just the chunks of the information, but also the metadata. So architecture. Again, the criteria is to have a highly available, distributed, eventually consistent object storage using community servers. And here's the trick. Eventually consistent. I will let you digest this idea of a storage system that decided to drop consistency. Meaning that if me and Bob were together, we want to work on the same file, and I just upload a new version of a file. A millisecond later, Bob wants to read this file. Maybe he's getting the old version because the system hasn't replicated this stuff. Maybe he's in the other part of the wall, and his replica is closer to him, but his replica didn't get the latest version. And that's completely OK. You will get some metadata telling you which timestamp is your object. And me, as a uploader, I only get a update when it has been replicated at least once. You will see more details later if you want. What do we replicate is not just the object itself, like an image. I also replicate, well, Swift also replicates accounts, like our information, the user information, and the containers, which is like the directory listings. So everything is like something to be replicated. For those who are interested, the CAP theorem is something that is documented somewhere, and you can relate to many NoSQL or storage engines using a CAP theorem. And something I also discovered. Maybe people here will explain you more about that. So now the details and the architecture. Why is this? The funny thing is, I think that's interesting enough to bring this issue into a 101 on Swift. I kind of liked the approach of just having the visible part of Swift that remains closest to the customer. They call that proxy. This is something that it scales in a way, but the backend, the heavy servers with a lot of hard drives, you can pretty much do whatever you want with them. The proxies, though, is like something that it gets exposed. Okay, so the proxy runs the proxy server, the Swift proxy server process. It also deals with authentication and the middleware for plugging other stuff, the WSGI. And the storage servers is where the actual things get stored. It runs Swift account server, Swift container server, and et cetera, et cetera. So they deal with the three kind of objects we mentioned earlier. So how it works. The proxy tier is something that, again, it connects the user to the storage solution. It scales horizontally. It's quite easy to make, add another proxy and have another public IP and thing. The next tier, the ring, is something quite honestly complex. I found it complex to understand. It's like an algorithm, and also it's like an object that resides somewhere. And servers altogether use this ring to know where to put stuff. It uses an algorithm, a hash algorithm. It's documented later. For those interested, it uses MD5. And it's more like telling an object, OK, what's your hash? And my hash is 3, 4, 5, So, OK, you start by 3, meaning you start with 3, you go to the server number 3. So everybody knows the algorithm. The algorithm is like a file somewhere sitting around being replicated. But everybody agrees on which version of the algorithm they have to use. So they know the logic is not even distributed. It's like an algorithm. It's like calculating P. So this algorithm, the ring, decides where to put an object. So they pick the servers based on the speed of the server, the size of the server, and many other parameters. And those servers are the storage zones. Usually people put them in different bays or even in different data centers. And you try to isolate them to avoid failures. So that stuff gets replicated on many zones. And automatically, thanks to the ring, the best storage zone is chosen. So how do writes work? Again, provided the 3 replication factor, which is by default. Once we've written on the first 2 servers, and we get a quorum, like, OK, it's being written. For the third one, we let the threads to work, but the OK is immediately sent back to the user. So they don't have to wait until the Hong Kong replication ends. Okay, you don't have to wait for that. You get an OK, and you know that the system will deal with the replication itself. But when you want to read, the system also provides you the closest replica, so you get a faster read. By the way, I've read, correct me if I'm wrong, it's not really good idea to have long reads, I don't know, like a huge file to be put in Swift. If you want to read that from multiple, like a streaming solution, something like that, you're better off caching this thing as an edit over a CDN. Anyways, for most of the cases, this is good enough. And also another advantage is that replication is like a thread that runs autonomously. And if anything happens, it can be detected reactively, like, OK, it has been broken. I want to write. It's not available. So they start up a replication process, like a self-check. And there's also an automatic self-check in the background, running over all the files and making sure that every checks and matches the file is stored. So text. I love text in slides, OK? I don't want to annoy you showing you all this text. But I've provided all the features, more or less, like I've been explained. And everything's documented here. If you later want to download and go over every feature. From here, something I like is the temp URL. It relates to Amazon S3. You can get a URL and say, OK, this link is only available for 2 hours. Sometimes it's useful. Okay? ACLs, again, is something very powerful. Access control list, for those who don't know. Also, large objects, as I said, it can be splitted for upload. By default, I read that it's like a 5 gigabytes limitation. But even if internally it's going to be split in 5 gigabyte chunks, because you have to split them on upload, there are tools to automate the splitting and merging things in both on the client and the server side. Actually, the server is completely transparent. And internally, you can make the files as big as you want. And they will be downloaded from multiple replicas and at the same time and merged in the proxy. It's quite advanced. Last but not least, the Swift 3, again, this is an additional module that you can put and make your Swift cluster compatible with any S3 management tool. So the API, again, remember the analogy. Swift or object storage is like an FTP or like WebDAV. So you just have commands, HTTP commands like get, post, delete, head options. You get HTTP return codes. You have headers like cookies, and you have many headers. And it's very easy to port this thing to multiple languages. So you have Python, Ruby, Java, and command line tools existing, and graphical tools as well as the one I wanted you to show, Cyberduck. S3 Fox as well is quite old, but it works. So from the command line, there's a Python Swift client. You can delete, download, list, post, stat, upload, and ask for capabilities of the server. And note here, technical note, the post is mostly used to modify metadata. And here's the link with the features I've showed you but not explained. And for instance, if you want to apply an ACL, you post a header. You post in an object, and you set up a header value on the X account access control header, and you just put the whatever. I think some of them accept JSON, and some of them are just text, or some of them are even integers. Again, a lot of documentation that's very, very, very low level. But so you see the respect for the standards being kept here. Okay, everything is HTTP, and everything that adds to the HTTP standard is on a HTTP header with an X, which the standard is meant to use this way. So we have metadata for ACLs. Rate limit is limiting the rate of changes. For the dynamic large objects, for object versioning, again, you can put the same image, different versions, and keep track of all the versions. That's good for web development, for instance, or for any other applications. You have a container synchronization. You can mark one container in my local Swift cluster, another container in the Hong Kong data center, and I can mark them for automatic replication, so they can have like subfolders in sync, and I do nothing. It's done automatically. Object expiration, again, is like temporary URLs, but even more powerful. The object can be actually destroyed after a while. And also some cross JavaScript thing called course that I really didn't understand. Anyways, so my demo using Cyberduck is not available. I'm just going to scroll to the last page. So don't mind the strange things going to happen, because yep. There you go. The instructions, this command line. This is Cyberduck tool on Mac. Sorry about the mic thing. On Mac, you install these things, open source. You just add a profile called OpenStack Swift. And if you don't use HTTPS, which in my test environment, I don't have it. So I have to put Keystone HTTP, the server, the tenant. You know, and username says Marcos Garcia. The first part is tenant. It's like a group or like a customer, you want to call that. And my username on the password. And actually, the URL I'm using is not Swift. It's the Keystone URL. That's a concept of OpenStack that I really invite you guys to look further. And if you really want to understand how Keystone works, is the glue, you know, the piece that glues together all the pieces of OpenStack, including Swift. and is the central point for all service catalogs and authentication mostly. But once I'm authenticated, I ask Keystone in this URL, hey, what's the object storage URL? And I actually don't do that. It's Cyberduck. He gets the URL, the port. And for instance, Swift is in the port 8080, but I don't put that there. He just automatically discovers where's the URL. And in the second step, internally, he connects to the actual Swift cluster. Once I'm connected, I get my bucket called the Swift, and I have a couple of files. And if I ever right-click on an item, I could add metadata and set up some properties and things. So this is my presentation. I'm open for questions.